Hi all. In this video, we will discuss the topic of number of solutions of a pair of linear equations. Let's see what all we are going to cover in the session. First, we would be examining the possible number of solutions of a system of linear equations. We will understand what are the conditions to determine number of solutions and also solve different types of MCQ questions which can be asked from this topic. In your NCERT textbook, this topic comes under exercise 3.2 under the heading graphical method of solution of a pair of linear equations. When you draw the graph of a linear equation on the XY plane, the shape that it takes is in the form of straight line. And any point on this straight line represents a solution of the linear equation. When you're drawing a pair of linear equations in the XY plane, that means that you're having two lines. Now, two lines could be intersecting, they may be parallel, or they may be on top of each other, lying on top of each other, meaning they are coincident. Let's examine each of these conditions one by one. In the first case, the lines may be intersecting. If you have intersecting lines, it means that they meet at one point. And this one point would be the one solution to this pair of linear equations or to this system of linear equations. There is one solution for intersecting lines, and as such, we call this sort of system of linear equations consistent system and an independent system. These points are very important. By consistent, we mean that you are getting at least one solution. Is it possible to get a solution? Yes. And independent means that the values over here do not depend on each other. The equations as such are independent of each other, but they meet at a single point. So please remember all this for this condition. Intersecting lines, one solution, and the system is called consistent system or an independent system. Let's look at the case for parallel lines. When you have parallel lines, they never meet each other, which means there is no common point. No common point means no solution. And in this system, we call it inconsistent. You're calling it inconsistent because you're not getting a solution. For something to be called consistent, at least one solution should be there. This is inconsistent system where you're having no solution. And in case the two lines lie on each other, which means when you draw both the lines, they form exactly the same line. We call them coincident lines. And these sort of lines have infinitely many solutions because all the points are common on these two lines. And this is called consistent since you're able to get a solution. But this is a type of dependent system because they're not independent of each other. Both the lines are one and the same. So we call this consistent and dependent system. All right. Let's look at how we can identify what are the number of solutions for a pair of linear equations without having to draw the graph. So if you're having two linear equations, a1x plus b1y plus c1 equals 0, a2x plus b2y plus c2 is equal to 0. In this case, looking at the ratios of x coefficients, ratios of y coefficients, and ratios of the constants, we can determine which of the three systems we discussed it follows. So first thing, intersecting lines, unique solution, which is consistent and independent. How do we identify from the system of linear equations? It is only looking at x coefficients and y coefficients that we can say that it is intersecting lines. So here a1 by a2 will not be equal to b1 by b2. The ratio of x coefficients is not equal to ratio of y coefficients. You don't have to look at the constants. As long as this condition is fulfilled, it's intersecting lines. For parallel lines, what is the condition? a1 by a2 equals b1 by b2, but it is not the same as c1 by c2. So here we have no solution. It is inconsistent. It is independent itself, but inconsistent. Okay. So A1 by A2 equal to B1 by B2, but they are not equal to C1 by C2. And what about consistent and dependent systems where you have infinite number of solutions, the coincident lines? Now, these kind of lines, the condition would be all ratios are equal. A1 by A2 is the same as B1 by B2 and the same as C1 by C2. All of these ratios are one and the same. Okay. All right. Let us look at our MCQ questions now. The first question. How many solutions are possible for the following pair of lines? You are given two lines, 4x plus 3y equals 3, 12x plus 9y equals 20. You need to determine how many solutions are possible. Remember that for a pair of straight lines, you cannot have exactly two solutions. This is definitely not going to be the answer. It's either one solution, infinite solutions, or no solution. We need to determine which one of these it is. Here, you are going to identify A1 and A2 by looking at the x coefficients. Look at the x coefficients. This is going to be A1 and A2. You are having the ratio A1 by A2 as 4 by 12 or 1 by 3. To get B1 by B2, we look at the y coefficients. So y coefficients is 3 and 9. B1 by B2 is equal to 3 by 9, which is also 1 by 3. In case these two are not equal, we could have directly marked the answer as one solution, one unique solution, because that would be the condition for intersecting lines. But here, this ratio is the same. A1 by A2 and B1 by B2 are the same. Since they're the same, what should we do? We should check what C1 by C2 is also. So how do you calculate C1 by C2? Here you would notice that both the constants are given on right side of the equal to symbol. As long as the position is the same, both are to the right side, you can directly take the ratio over here. So let's find out what is C1 by C2. C1 by C2 would become 3 by 20, which cannot be reduced further. Quite clearly over here, you can see that A1 by A2 is the same as B1 by B2, but it's not equal to C1 by C2. Which condition is this? This is the condition for parallel lines. That means there is no solution. No solution would be the answer to this question. Okay. All right. Let's go to second question. The second question says, the pair of equations y equals 0 and x equals minus 7 has how many solutions? 1, 2, infinitely many solutions, or no solution? As I mentioned, we cannot have two solutions over here for these pair of equations. Answer for any linear system of equations has to be one solution, infinitely many solutions, or no solution. Let's identify what happens here. In this case, rather than writing this in A1, A2, B1, B2, C1, C2 form, it might be easier if you can draw these lines. Which is the line y equals 0? Y equals 0 is a horizontal line. In fact, y equals 0 is the x-axis itself. The x-axis itself would be the line y is equal to 0. What about the line x equals minus 7? X equals minus 7 would be a vertical line which is passing through the point minus 7, 0. This is going to be the line x is equal to minus 7. Please remember this. Y equals any constant is going to be a horizontal line, and x equals a constant is going to be a vertical line. Now, when you have a horizontal and vertical line, it means they are going to intersect, and hence the answer in this case would be one solution, because these are intersecting lines. What happens if you had y equals 0 and y equals minus 7? If this was the case, you would have had two horizontal lines and these would be parallel. They would never meet. In this case, the answer would have been no solution. What if you had x equals 0 and x equals minus 7? This would be the line x is equal to 0, the y-axis itself. and x equals minus 7 would be another line which is parallel to it. Now, these also will not meet each other. They will be parallel to each other, which means that in both these cases, we would have said that the answer is no solution. But when you have y equals some constant, x equals another constant, these two would meet at one point, which is the point they both meet at. Definitely, these two would meet at minus 7, 0, right? And hence the answer over here is one solution. Let's go to question 3. One equation of a pair of dependent linear equations is 2x plus 5y equals 3. So the equation given is this: 2x plus 5y is equal to 3. We need to find out what the second equation could be. Now, important word in this question here is this one, dependent. What does dependent mean? Please remember, dependent system means that the two lines have to be coincident. They have to be on top of each other, right? And for coincident lines, what is the condition? The condition is A1 by A2 equals B1 by B2 is equal to C1 by C2. This is the condition. So we need to see which of the given answer choices satisfies this condition with the given equation. Let's find out this ratio for each of the answer options. Now, doing this is not compulsory. That means writing it this way. This is just for explanation purpose. You may also just go through all the options and calculate this in your mind. So if you're looking at option A, let's see what A1 by A2 becomes over here. A1 by A2 over here for option A would be 2 divided by this 2. Right? So this is 2 by 2, which is equal to 1. What is B1 by B2? B1 is 5 and B2 is also 5. So you're getting 5 by 5, which is also equal to 1. Here A1 by A2 is equal to B1 by B2. Let's continue checking for C1 by C2. So C1 over here is 3 and C2 over here is 6. 3 by 6 would become 1 by 2. Note over here that C1 and C2 over here both are on the right side of the equal to. So the same pattern should be followed for both the equations. What do we get here? We get here that A1 by A2 equals B1 by B2, but it's not equal to C1 by C2. So this is not dependent sort of system. These are parallel lines, which is independent. Let's check out the next one. A1 by A2 here would become 2 divided by this 3. So you're getting 2 by 3. B1 by B2 would be this 5 divided by 5, which we are getting as 1 again. And what's C1 by C2? C1 by C2 over here would be 3 by 3. But was this important? Was it necessary to continue to C1 by C2? Not necessary, because here itself we got A1 by A2 is not equal to B1 by B2, which means that this is a system of intersecting lines which has a unique solution. So this is not the answer we are looking for over here. It is an independent system when you're talking about intersecting lines. Let's look at option C. What is A1 by A2 here? You're having 2 divided by this minus 10. 2 by minus 10 would be equal to minus 1 by 5. What is B1 by B2? B1 is this 5 and B2 is this y coefficient, minus 25. So you get 5 by minus 25, which is again equal to minus 1 by 5. Here, since A1 by A2 is equal to B1 by B2, we can continue. What is C1 by C2? C1 is this value 3. And what is C2? Is it minus 15? 3 by minus 15 and then you get minus 1 by 5? Is that correct? No, it's not right. Why is it not correct? Because here the constant is coming to the right side of the equal to symbol. However, here the constant is to the left side of the equal to symbol. We need to make both equations look the same format. To change this option C to the same format as the question, we need to move this minus 15 to the right side, making this plus 15. So this ratio here would not be 3 by minus 15. It will be 3 by plus 15. And this would be 1 by 5. So you can see over here, this is not the answer. These are actually parallel lines because A1 by A2 is equal to B1 by B2 but not equal to C1 by C2. So these are parallel lines. This is not the answer choice. Please be careful about this. Let's check option D. In option D, we have A1 by A2 would be 2 divided by 10, which is equal to 1 by 5. B1 by B2 is 5 divided by 25, which is again 1 by 5. And C1 by C2 is 3 divided by 15, which is going to be 1 by 5. So A1 by A2 is equal to B1 by B2 and it's equal to C1 by C2. This is a condition for dependent linear equations. D would be our answer. All right. Next question, question 4. Which pair of equations is represented by the graph given? So you're having over here two parallel lines drawn and you need to identify among the options which could be the equations of these two parallel lines. Now, when you're having parallel lines, what should be the condition followed by the coefficients of xy and then the constants? If you look at the ratios of these, you should get A1 by A2 equals B1 by B2, but not equal to C1 by C2. Now let's see where this is getting satisfied. If you look out here and here, in both cases, A1 by A2 is the same. A1 by A2 is 6 by 2, which is equal to 3. Look at the y coefficients, minus 3 by minus 1. And here also you have minus 3 by minus 1. Minus 3 by minus 1 both would be 3. So you can see that both of these are cases where A1 by A2 is the same as B1 by B2. So this part is okay. Now you need to ensure it is not equal to C1 by C2. If you look at C1 by C2 over here, you're getting 10 by 9. Clearly, A1 by A2 is equal to B1 by B2, not equal to C1 by C2. And what about this one? You're having 12 by 4. 12 by 4 would be equal to 3. In this case, A1 by A2, B1 by B2, C1 by C2 is the same. That means these are not parallel lines. They are coincident lines. This cannot be the answer choice. What would be the correct answer then? The correct answer has to be option A, where you are having A1 by A2 equal to B1 by B2, not equal to C1 by C2. In this case, answer is not both of the above, but you're seeing there's an option called none of the above there. You're having an option D, none of the above. So what if, even though the option A represents parallel lines, what if it is not the equation of the graph which is given in this diagram? How do you verify whether it is the equation of the graph given in the diagram? Because when you see option A, all you discover is its parallel lines. It could be any set of parallel lines in the XY graph, right? You could have parallel lines drawn anywhere. How do you know that these are equations for these set of parallel lines only? We are thinking in this way because this none of the above option is there. What I want you to do in this case is look at some points at which the graph is intersecting the x and y axis. So if you're looking at this green line, which is representing equation 1, you can see that there is a point over here, which is roughly, I could say that this is 0, 3.5. Roughly, it's a value between 3 and 4 over here, right? Let us see whether this gets satisfied for the first equation. The first equation says 6x minus 3y plus 10 is equal to 0. Let's put x is equal to 0. When I put x is equal to 0, we are getting minus 3y plus 10 is equal to 0, which means y is equal to minus 10 by minus 3, which is 10 divided by 3 or 3.333. So yes, this answer, this option should be correct. It lies on this graph. 3.333 is the actual value. I had estimated it to be 3.5 by looking here. So yes, this looks like this is the graph of equation 1. Now, if you look at the second one over here, you can see that this one has a point. Look at this one. This one is an exact point. This one has a point minus 3, 3. So let's see whether this point satisfies the second equation or not. The second equation is 2x minus y plus 9 is equal to 0. So the LHS, when we substitute this minus 3 and 3, will be 2 into minus 3 plus 9. This is going to be minus 6 minus 3 plus 9, or minus 9 plus 9, which is 0. Same as the RHS of this equation, which means that this point is satisfying the second equation. So yes, we can confirm that this in fact must be the answer, option A. It won't be none of the above. Okay, so be careful about this. When you're having options like none of the above, you need to confirm and verify that yes, the graph which is given is indeed the graph of the equations which is given over here. All right. Okay, let's continue to fifth question. The fifth question asks, for what value of k do the equations 5x minus 2y plus 8 equals 0 and 15x plus ky equals minus 24 represent coincident lines? Now, whenever you get such sort of questions, please make sure that both equations are written in the same form. The x values first, y values second, constants third. Okay, and constant should be on the same side of the equation. If I am writing the first equation as 5x minus 2y plus 8 equals 0, second equation should have the x term first, 15x, the y term second, which is plus ky. Here, minus 24 is coming on the right side of the equation. In the first equation, the constant is on the left side. So make sure here also it is on the same side. You will change this to plus 24 is equal to 0. Once you have this, you need to identify for what value of k this has coincident lines, right? So we will see what is a1 by a2, b1 by b2, and c1 by c2. a1 by a2 would be 5 by 15, which is equal to 1 by 3. b1 by b2 would be equal to minus 2 by k. How do I get this minus 2 by k? Minus 2 is the coefficient of y. Please be careful to take the sign, negative sign along with this. And the coefficient of y in the second one is k, the number which is multiplied with y. Now, your instinct might be that once you see that you need a value of k such that this represents coincident lines, your instinct may be to equate a1 by a2 to b1 by b2. Since we know that the condition is a1 by a2 equals b1 by b2 equals c1 by c2. So you might be equating 1 by 3 to minus 2 by k, and hence getting k is equal to minus 6, and then marking that as the answer. But this is a wrong approach. Please, when you're trying to find out coincident lines, ensure that you also find the value of c1 by c2. We found a1 by a2, we found b1 by b2. We know that they should be equal if they were coincident lines, but please take time to find out what is c1 by c2 here. c1 by c2 over here is 8 by 24, which is 1 by 3. Only in the situation where a1 by a2, whose value you know, 1 by 3, is equal to c1 by c2, which is 1 by 3, should you continue. In case you got c1 by c2 as a different value, suppose c1 by c2 was minus 1 by 3, or suppose c1 by c2 was 2 by 3, it is not matching a1 by a2. What would be the answer then? You would say the answer is none of these. Because if a1 by a2 was not matching c1 by c2, this cannot be coincident lines. How are we sure that yes, this could be coincident lines? Because the places where you're getting the value, the values are becoming equal. You're getting 1 by 3 equals 1 by 3. So then yes, you could do what we did earlier. You can say 1 by 3 is equal to minus 2 by k, and k is equal to minus 6. So I repeat over here, ensure that you are verifying that all the three ratios are the same. If all the three ratios are not the same and they ask which value of k represents coincident lines, you should say the answer is none of these in that case, because there would be no value of k for which it would be coincident lines since the ratios are not becoming equal. In this case, however, we found that A1 by A2's value is matching with C1 by C2. All we had to make sure was make sure that B1 by B2 also matches this value. And hence we get K is equal to minus 6. I crossed it out here earlier to again reiterate the fact that don't directly calculate K over here without verifying whether C1 by C2 is the same. Okay. All right. Question number 6. If the lines given by 3x plus 2ky equals 2 and 2x plus 5y plus 1 equals 0 are inconsistent, then the value of K is. What do you mean by inconsistent lines? That's the condition of what type of equations? Inconsistent lines is the condition for parallel lines, right? When you are having inconsistent lines or inconsistent system of equations, it indicates lines which are parallel, for which you can find no solution. So what's the condition for no solution? It will be A1 by A2 equals B1 by B2, but this value should not be equal to C1 by C2. Let's check out what these are. First, by making sure both equations are written in the same order. So you're having the first equation as 3x plus 2ky equals 2. We will write the second equation as 2x plus 5y is equal to minus 1. I'm making sure that for both the equations, the constant is on the same side. What is A1 by A2? A1 by A2 is 3 by 2. This should be equal to 2 by 5. Is it 2 by 5? No, it's 2k by 5. Whatever number comes before y. So you're going to make this equal to 2k divided by 5. And it should not be equal to 2 by minus 1. First thing you verify, 3 by 2 should not be equal to 2 by minus 1. Well, that's right. 3 by 2 is not equal to 2 by minus 1. In case 3 by 2 was equal to 2 by minus 1, then you would have said, no, this can never be inconsistent, right? Because then it would be infinite solutions. But here it is okay. 3 by 2 is not equal to 2 by minus 1. And hence we can continue finding the value of K. So we equate these two, A1 by A2 to B1 by B2. We are going to cross multiply and get 15 is equal to 4K. Or you can say K is equal to 15 by 4. 15 by 4 is the answer to this question. Question 7. The value of K for which the system of equations kx minus y equals 2 and 6x minus 2y equals 3 has unique solution is. Now, what's the condition for unique solution? For unique solution, you just have to be bothered about A1 by A2 and B1 by B2. C1 by C2 does not affect this at all. Just make sure that A1 by A2 should not be equal to B1 by B2. That's it. Which are the x coefficients here? We are having k and 6. K by 6 must not be equal to B1 by B2. What's B1? B1 is the coefficient of y here, which is minus 1. And B2 is the coefficient of y in the second case, which is minus 2. So the condition is k by 6 not equal to minus 1 by minus 2. Please retain this not equal to sign. You get minus 2k should not be equal to minus 6. That's the condition. Minus 2k not equal to minus 6. If this is the case, what do we have? We have 2k not equal to 6, which means k not equal to 3. The answer over here is k should not be equal to 3. Some of you may skip writing this not equal to step over here and mark k is equal to 3 as the answer. Please be careful about this. When we are having unique solution, what we have to put is the not equal to symbol. So what this means is that for any value except k, any value other than k, you will have a unique solution over here. If k is equal to 3, no, you cannot have a unique solution. So the condition is k should not be equal to 3. Okay. Let's summarize what we learned in this session. Well, what we learned in this lesson were the conditions for finding how many number of solutions a system of linear equations could have. When you are having two linear equations, it's possible to have a unique solution, no solution, or infinite solutions. When do you get a unique solution? When the lines are intersecting. This is also called consistent system or an independent system. Here the condition would be A1 by A2 not equal to B1 by B2. Zero solutions, no solutions when the lines are parallel. They do not meet at all. No solution means inconsistent. You're not getting a solution. So inconsistent. Here A1 by A2 would be equal to B1 by B2, but not equal to C1 by C2. And when do you get infinite solutions? When both lines represent one and the same, because they are just one equation multiplied by a same quantity. So here you would say A1 by A2 is equal to B1 by B2 equals C1 by C2. This is a consistent system because you're obtaining solutions. So it's consistent, but it is dependent consistent because both are essentially the same lines. All right. Thank you so much for watching. I will see you in the next lesson. Bye-bye.